Alright, so we're going to go ahead and take a look at an example that's in your notes. This happens to be question number 1 here. So we're going to go ahead and graph the log base 2 of x. Now, as I mentioned in the last video, a log is simply the inverse of an exponential. So what I want to do is I want to take a look at not this, but the exponential of this. Alright, so first of all, the exponential for the log base 2 of x would simply be log or y equals 2 to the x power. So notice 2 is the base and x being the exponent. Okay, so I'm going to be looking at this function or this equation rather than this one here. That's what I'm going to start off with anyway. Alright, so we're going to go ahead and create ourselves a table. Okay, we're going to create a table for y equals 2 to the x power. So the first thing I'm going to need are some x values. So the x values that I'm going to use here are going to be a -2, also going to use -1, going to use 0, we use 1, 2, and 3. Alright, so now that I know what my x's are, now I'm going to calculate the y's. Again, remember, I'm looking at this exponential here. So first of all, 2 to the -2 power would be 1/4. 2 to the -1 would be 1/2. 2 to the 0 power would be 1. 2 to the first power would be 2. 2 to the second power, or 2 squared, would be 4. And finally, 2 to the third. 2 to the third is 8. So all I've done is create a table for the exponential. Alright, now I'm not going to graph this because that's not what I was asked to graph. I was asked to graph log base 2 of x. So what I'm going to do now is I'm going to take this table that I've just created and I'm going to swap the x and y. So I'm going to create myself a new table, and in this new table all I'm going to do is swap these x and y's. So now that first order pair is going to become 1/4 -2. And the next order pair now becomes 1/2 -1. The next order pair now becomes 1, 0. Remember, all I'm doing is swapping the x and y's. The next order pair becomes 2, 1. The next order pair becomes 4, 2. And the last order pair becomes 8, 3. So again, all I'm doing is swapping the x and the y's. At this point, I can go ahead and connect my points, or plot these points. Alright, so let's go ahead and start plotting these points. The first one being 1/4 -2. Now it's going to be kind of tricky here. So 1/4 is just really close to that y-axis, and -2 roughly right about here. The next point we have is 1/2 -1. So that'll be somewhere right around that area there. Next point being 1, 0. So that's going to be right about here. Next point I'm graphing or plotting is 2, 1. 2, 1 is right about there. 4, 2. I'm looking for 4, 2. 2, 3, 4, 4, 2. Right about there. And then the last one we have is 8, 3. Alright, so 4, 5, 6, 7, 8. 3 right about there. Okay, so at this point I've plotted my points. Now what I want to do is I want to connect these points. So let's go ahead and do that. And it's going to look something. Let's see if we can do this here. Connect these points. Look something like this. Okay, so that right there is the graph of log base 2 of x. Alright, so now that we got that graph, let's go ahead and look at a couple of characteristics here. First one being the domain. The domain for this particular graph is going to be from 0 to infinity, and that's because we never crossed this y-axis. Remember, that's our asymptote here. Okay, so we got all of this graph staying to the right hand side of the y-axis. We're going from 0 to infinity. The range, on the other hand, is going to be from -infinity to +infinity, and that's because this graph will continue to go down further and further and further, and this graph will increase gradually forever and ever and ever. Okay, so the range is from -infinity to +infinity. Now let's look at the end behavior of this graph. First one we're going to look at is as x approaches infinity, meaning as this graph is moving towards the right here, as it's going towards the positive x's, notice that the y's, or the function itself, is going to increase. It's going to keep getting bigger, bigger, and bigger. It's going to approach infinity. Now if I go the other direction, as x approaches 0, okay, so now I'm going this direction here. As x approaches 0, now what's happening is that the y's are going down. They're going towards negative infinity. Okay, so that's the end behavior for this particular graph. The x-intercept for this graph, which was this point right here, is 1, 0. By the way, you can also see that in your table right here. And then the asymptote, as I just mentioned, that's this y-axis right here. This graph will never cross over that y-axis, and the equation for that line is x equals 0. Okay, so you're going to have some problems just like this in your assignments. What you're going to do is change the log to an exponential, like I did here. Log base 2 of x now became y equals 2 to the x power. Create yourself a table for this exponential, and then just swap your x and your y's. That's going to create this table of values over here. Once you got your table of values, plot those points, connect those points, and now you have the graph of log base 2 of x. Alright, good luck guys, give it a try.